5.3, multiplying polynomials. We're going to do a lot of distributive property, and we're going to FOIL, if you remember what that means. And then this is the really important one. We're going to use special products formulas to help us multiply two binomials. So this first one might seem really easy to you, but once we get to special products, I need you to pay close attention, especially because I'm gone and you're not going to have me to answer any of your questions in person. Okay, so pay attention, especially when we get to the special products. If you're bored during the first one, tune back into the special products one. Okay, so let's start off with monomials. Remember, monomials are single terms, and binomials are two terms. So here we have a binomial in the first parentheses. There's two terms times a monomial. Okay, so all we have to do is take this monomial and multiply it times both of these two terms. So 3x times 2x, if you can imagine what that looks like over here on the side, 3x times 2x. Well, 3 times 2 is 6, and x times x is x squared. Okay, so when I multiply those two terms, I get 6x squared. And my next one, I have a 3x times a negative 7. Okay, so I'm just going to multiply the numbers, and I get negative 21, and it's being multiplied times x, so I get negative 21x. Now you may not have to do this off to the side. I was just demonstrating that when you multiply, you have to write x squared. It's not 6x. You're not adding. It's not 2x plus 3x. And you combine like terms to get 5x. That's not what this is. It's multiplying. So an x times an x is an x squared. Okay, I'm going to go down here and do this one. A negative monomial. Negative x needs to be multiplied times the 5x squared. So I have a negative 1 times a 5 would be a negative 5, and an x times an x squared. That means there's 3 x's being multiplied, so that's an exponent of a cubed. Negative x times negative x. Now notice how I did that up here. I took my 3 times a negative 7 and a positive 2x. This is a negative x times a positive 5x squared and a negative x. So always keep that sign in front of it. Okay, so a negative times a negative would be a positive. X times x is x squared. It is not 2x. All right, I'm going to go ahead and let you solve both b's for me and make sure that you are distributing to all three terms and make sure that you're careful of the sign in front of what you're multiplying by. Okay, on the first part B, you should have gotten 12x cubed minus 8x to the fifth and plus 4x squared. Make sure you multiply all three of them, and that's a negative 2. So make sure you have a negative 8 there. Down here, you're distributing a negative 2x squared. So you get negative 2x to the fourth after you multiply it times the first one. The second one is a negative times a negative. So you get a plus 16x cubed, and then negative 8x squared. All right, multiplying two binomials, we're going to use the FOIL method. FOIL stands for first, outer, inner, and last. It's just telling you that you need to multiply each term in the first binomial times each term in the second. So you start with the first terms. So in this parenthesis and this parenthesis, those are the first terms. So 3x times 2x is 6x squared. Then you go ahead and do the outer. So the two outside terms on the very outside are the 3x and the 7. The 3x times 7, remember we're multiplying, that's why these parentheses are hugging. There's a multiplication symbol in there. So I'd get 21x. Okay, now I need to do the inner numbers. Inner numbers are the two in the middle. So a negative 2 times a positive 2x would be a negative 4x. Those are the inners. And then the last numbers. The last numbers would be that -2 and that 7 because it's the last in both parentheses. So I'd get -14. Okay, now I'm going to combine like terms to simplify here. I can't combine anything with my x squared. If you remember from section 1, I can take my positive 21x and my negative 4x and combine those. So I'd get plus 17x. And then I have my minus 14. And that's all the further I can go. No more like terms. All right, go ahead and try part B using the FOIL method. Okay, so on the first one, you should have gotten 6x squared plus 17x minus 14. Oh, we already did that together. Sorry, the second one we did, you did x squared minus 9 would be your final answer. After you combine the like terms, they cancel out. Okay, I want to practice a few of these multiplying polynomials. So it could have, it's not always going to be just a monomial or a binomial. It could have 3 terms in one of them, 3 terms in both of them. So I want to practice a couple of those. We just make sure we distribute each term in the first to every term in the second. Okay, so go ahead and just start with the first. 2x squared times 3x would be 6x cubed. And then you just keep going. You give it to the first one, now give it to the back one. So a 2x squared times a -4 is a -8x squared. And then you hop over, so you gave that to each, so you gave this first term to every term in the second parentheses. Now we're on to the 6. We need to give this term to every part of this parentheses. So 6 times 3x would be 18x positive. A positive 6 times a -4 would be a -24. Okay, now we go on to this position. -5x needs to be multiplied times the 3x, so -15x squared, because x times x. -5 times -4 would be a positive 20, and there's an x with that. And now you just combine like terms, so you don't have any cubes, but you do have a couple squares that you can combine. So -8 and -15, -23x squared. You have 18x and 20x, combine those to give you 38x. And then you have a -24 that can't be combined with anything. And that's your final answer. So just be careful on those, especially the signs. Keep that subtraction sign with the 5x and keep that subtraction sign with the 4. That way you just treat them as negatives. Okay, we're not going to use the vertical form. I don't like it very well, so we're just going to do it horizontally again. But I want you to try it, so make sure that you are multiplying every term in the first parenthesis to every term in the second and combine like terms for me. All right, let's go ahead and see how you did. When you take your 4x squared times everything in the second parentheses, you get 20x squared plus 12x cubed minus 4x to the 4th. Then go ahead and move to the second term, this x, and multiply it by all 3 in the second parentheses, so 5x plus 3x squared minus x cubed. And then move to the -2. Remember, treat it as a -2 times a positive 5, so you get -10, -6x, and then a positive 2x squared, since it's a negative times a negative. Now, you need to be careful when you combine like terms. I wrote mine in standard form. Yours might look a little different, but you should have 1x to the 4th, or sorry, -4x to the 4th. Nothing to combine that with. You do have a couple x cubes, so 12x cubed and -x cubed would be 11x cubed. And then you have 3x squared terms, so 20x squared, 3x squared, and 2x squared make 25x squares. And then I have a 5x and a -6x, so that's -1x, and I have a -10 with nothing to combine it with. Okay, the special products, like I said, are very important, so make sure you're listening carefully. If you understand it, find someone around you who doesn't and help them out. And also just refer to your notes. The more examples that you see, the better off you'll be. But this is what we're going to be using a lot of in this chapter. When we talk about factoring, it gets pretty hard. And I really need you to pay attention to these special products and know how to recognize them. So when we're looking at these, I want you to keep in mind that U and V can be numbers, they can be variables, or they can be expressions. So it could be like a number 7, it can be a variable x, or it could be an algebraic expression like 7x. Okay, so keep that in mind. Now, we're going to talk about 3 different special products. The first one is the sum and difference of 2 terms. So let's say you have this binomial times this binomial, and they're the exact same, except one is an addition and one is a subtraction sign. So that's the only thing different. Then sure, we can always multiply this the long way, right? We can do the FOIL, first, outer, inner, and last, and get our answer. But this is a shortcut. These special products are shortcuts. So if you see this, everything's the same except one's an addition and one's a subtraction, your answer is always going to be your first term squared minus your second term squared. Okay, so let's look at this example. Everything's the exact same. I have a 3x and a 4, but look what's different is a subtraction sign and an addition sign. Well, when that happens, I can take my first term and square it, right, u squared, and subtract it with my second term squared. Second term here was 4. The first term was 3x. So what does that look like? Well, 3x squared is 9x squared, and 4 squared is 16. So your final answer is 9x squared minus 16. And I didn't even have to FOIL. Let's look at this one, the square of a binomial. This is another special product. It saves us some time. It'll say u plus v squared. Remember, u and v can be anything. So you're taking a binomial and you're squaring it. So what does that mean? What does squared mean? Well, it means take it times itself. And I could FOIL, right? First, outer, inner, last, but this is a shortcut. What you can do is take your first term and square it and put it in the front. Look at your last term, square that, put it at the back. And in the middle, you're going to take 2 times your first term times your second term. And if your sign is an addition sign, both of these need to be addition signs. And if you're ever confused, just please come back and look at this rule. It does no harm to go back and look at your notes. Don't ever guess. Okay, so let's say we're starting with 2x plus 5 and we're squaring it. That's a square of a binomial. Okay, so the rule is I can take my first term and square it. So 2x squared would give me 4x squared. I can take my last term and square it. So 5 squared is 25. I put that at the back. Remember, in the middle, I take 2 times the first term and the second term. So 2 times the 2x and the 5 would give you 20x. 2 times 2 is 4, times 5 is 20, and there's an x being multiplied. And I never had to write it out the long way. Remember, this does not mean distribute the 2 to both of them. It's not what squared means. It means take this 2x plus 5 times itself. Okay? Now the only time, or you may think that you can distribute that 2, but that's only if it's if there's not a polynomial in here, if there's not a binomial in here, if it's just one term. Okay, what if that sign is subtraction? What if you're still squaring a binomial, but now instead of addition, you're subtracting? Well, same thing. First term squared, put it in the front. Second term squared, put it in the back. In the middle, you still have 2 times u times v, so 2 times both of your terms, but now this sign becomes subtraction. The back one is addition. Okay, so always be careful with that. Like for this example, it says x minus 6 squared. Your first term is x, so square it, put it in the front. Second term is 6, square it, put it in the back. It's Got to be addition. And in the middle, you take 2 times both of your terms. So 2 times x and 6 would give you 12x. And make sure that sign is negative there. Let's look at some more examples, because the more that we do these, the more comfortable we'll get. So, yes, when you see this, you could certainly FOIL. It's just going to take you a little bit longer. So we're going to do the shortcut method and recognize that this is a special product because I have matching terms, but the only thing that's different is the sign. One's subtraction, one's addition. Okay, so if I go back and look, that's this one. It's a sum and difference of 2 different terms. A sum and difference of 2 terms. The exact same 2 terms. So what can I do? Well, I can square the first term, square the second term, and plop a subtraction sign in there. So if I square the first term, I'd get 9x squared, right? 3x squared is 9x. And if I square the back term, I'd get a 4. And plop a different sign in there, a subtraction sign. So this part you don't have to write. I'm just writing it out for you so that you can see how I'm getting my final answer. So this equals that. And I didn't have to FOIL. If I did FOIL, and I would simplify it, I would get 9x squared minus 4. So if you did FOIL, that's fine. You'd get the exact same answer, it just takes you longer. Go ahead and try part B. Again, this is just like part A, but except different numbers. So best of luck. Okay, hopefully you came out with 36 minus 25x squared. Now what I want you to notice is this is just like the first one. It's a u plus a v and a u minus a v, right? Our u is our 6, our v is our 5x. So this is the sum and difference of 2 terms, u and v. So what can you do? You can square the u, square the v, and subtract them. So I squared the 6, squared the 5x. So that's how I got 36 minus 25x squared. Again, you don't have to show all of this work. It's a shortcut for a reason, okay? The third one, it says 2x minus 7 squared. So I'm taking a binomial and I'm squaring it. So square of a binomial. And I just want to make sure I get the right sign. So look at your sign at subtraction. So now we're down on this one, subtraction. And let's follow what it says. It says square the u, square the v, put them in the front and the back. So remember, this is my u and this is my v. So if I squared the 2x, I would get a 4x squared. And if I squared the 7, I'd get a 49. And now this subtraction sign is going to tell me the signs are negative and then positive, so minus and then plus. And this middle term, how do I find it? Well, I take 2 and multiply it times the u and the v. So I'm taking 2 times the u, which is 2x, times the v, which is 7. So 4x squared, what would all of this multiplied be? Well, I'd get negative 4 times 7, so 28, and the x there, plus 49. And there are no like terms to combine. This is an x squared, this is an x, and this doesn't have one. Now the last one says x plus 4 cubed. So wait a minute, I don't have that here. Well, what is x plus 4 cubed mean? It also means x plus 4 squared times x plus 4, right? I have how many x plus 4s being multiplied here? 3 of them. Okay, so what's x plus 4 squared? Oh, hey, now I'm here. I'm squaring a binomial and it says plus. So I'm going to follow this square of a binomial. And I want you to do that now. Just tell me what x plus 4 squared would be. Okay, hopefully you got x squared plus 8x plus 16. Okay, so what do you do when you're taking a binomial and you're squaring it? You square the first term, you square the second term, and in the middle you write 2 times the x times the 4, so that would give you 8x. And 4 squared is 16. Okay, so you just took care of that part, and you got this. But you still have to take it times the other x plus 4. So now we're back to the beginning of our notes where we distribute to every term. So why don't you go ahead and do that and finish out the problem and make sure each term in the first is getting to each term in the second. Okay, hopefully when you distribute you got x cubed plus 4x squared plus 8x squared plus 32x plus 16x plus 64. Then combine your squares and your x's to get a final answer of x cubed plus 12x squared plus 48x plus 64.